So first of all, thank you very much to invite me from Tokyo to Denmark. So today I talk for the energy policy in Japan, especially what happened after Fukushima 2011. This is my start point, 1984. It's a building 402 and the third floor. This is my research career start. And also 2001 at the Windsor conference, first Windsor conference, we are together with Fanger and Jan Toften and Vianney and Byron Jones, myself and Ken Parsons. So it's already 16 years ago. And also I found somebody, is a very clever guy in California for doing indoor air. He's already have chairing the session of productivity and economics. So since then, it's so much study coming from the DDU and also for the energy related for productivity, performance, other aspect. So I start what's happened in Japan. Probably everybody knows the Paris Agreement, COP21. Maybe US, you have a problem. I don't know. But we promised 26% CO2 reduction in Japan, but actually very hard. But this time the government asked if the commercial and residential sector should reduce 40%. Industry is very efficient now at the moment. It's very difficult to reduce. So they promised for 7% only. And then we have so much thing for reduce the CO2. But of course, we have a very big earthquake, especially for the tsunami. This is one of the picture one of my friends took in close to Sendai, Fukushima area. Because house itself, it is as it is, but it's a tsunami wash out everything. Even the nuclear power plant and also for the fire power plant, it used to be more than 30% of our electricity by nuclear in Japan. But now only 3%. So all the plant is shut down and also very difficult to get the public consensus to use again. But of course, we don't have so much fossil fuel. It's more than 95% of the energy coming from Arabic countries, Indonesia, other countries. So that's why we have to consider. And this is a basic energy plan. So it's a cabinet approved 2014. This is mandatory compliance with the energy conservation standard after 2017, April. And for building over 2,000 square meter for floor area, it's very strict code. And also labeling scheme is start from last year. It's more mandatory one. And also zero energy building and zero energy building ready building will be introduced in newly built public buildings by 2020. And average of the new building by 2030. This is maybe target is almost same as in Europe. But also, sometimes in Japan, if energy conservation or feel cold, and dark, and hot, and wet, so that's why we input the sentence for improving the quality of life. Because energy and indoor climate and indoor air, it's very, very important for the both sides. And then it's a green building. We need a green building instead of the brown building. So it's my student drawing this picture. I like green building, but it's not brown building. Probably, how many people knows ESG? Raise a hand. ESG, nobody knows? It's ESG means environmental, social, and corporate governance. It's UN, United Nations, defined ESG recently. This is a principle for responsive investment. It's equal to ESG investment. For example, asset. So if you invest for the brown building, then it's for example, government funding. It's not allowed to brown building. And also for another asset, for example, some of the fossil fuel in the future may be less used than before. It means so you have to put in the money to the green one. And now it's around 1,600 companies sign up And now the total assets are over 20 trillion US dollars. So big money going to the green. So you can find out the report for the PRI. This is published in the PDF. And this is one picture. This is a building now, for example. This is green and wellness, high green and energy, and also maybe good indoor climate. And we call this end is a brown discount building because it's a cheap building. But in the later on, so if it's a building going to the green, this is the standard that it's asset. So almost no meaning. So if you build a very poor building for indoor climate and green, so you cannot make any money. So we should go to the green premium one, so instead of this one. And of course, it's important is to less energy and quality of life and comfort and productivity, and especially for the health aspect. Now it's very important thing for research. Of course, it's the behavior is also very important. So Yon Toften is also green hair now. Myself, it's changed for the last 30 years to change the green hair. This is green hair for sustainable. Gail Clausen too. Because of energy reason, we started a new labeling scheme for the building, housing, energy efficiency labeling system, BELS, by the government from last year. So I'm chairing for the government session for this labeling scheme. And then it's last year, almost 1 year, zero, because we start a new system. Then for last 1 year, it's now close to 80,000 houses and buildings have a labeling already. 1 year, boom, it's boom. So because for the ESG investment, real estate, so people want to put the money to have an energy efficient building and housing. And also for the zero energy building, sometimes for the 5th or 6th story building, it's very difficult to cover completely zero energy. So that's why we need a new definition in Japan. So we discuss a lot. And of course, it's first, this is for the design stage, not operation phase. We use a program to use a labeling scheme, and 50% less building is we call zero energy ready building. And 75% with the PV and the renewable energy, we call nearly zero energy building. And of course, it's a net 100%, it's a ZEB. So this is combined with labeling scheme. So it means for the 50% less building, energy conservation building, we call the zero energy building ready. So we call this is a ZEB family definition. So this is widely accepted. And of course, we have a big discussion for the plug-in, for the appliances. So plug-in electricity consumption is not included for the 50%. So take note that this definition cannot prove zero energy in the operation phase. And also for only on-site renewable energy is counted. Because for the building a certificate, it's very difficult to know off-site energy. But at the moment, feed-in tariff system in Japan, now we want to sell to the paper like light to the CO2 reduction for the feed-in tariff to reduce the money for the payment by the people. And this is the chart. First, the reference building is standard value is reduced 50%, but exclude without plug-in, and then renewable energy going to up to the zero energy ready or nearly zero energy and zero energy building. We call PEP also. This is one example, Takenaka Corporation, East Kanto branch refurbishment. So they use this building for 15 years. They change the radiant cooling and heating system, the other new system, and they proved to the nearly zero energy building. So they reduce 56% energy from the design stage, and then they put PV system, it's less than 75% more energy less than before. So this is already certificated. And also new one coming from February this year. I don't know, you know, the Lawson, the company like 7-Eleven, the convenience store. So they made a zero energy store already. They opened already in Tokyo. So 60% cut down the energy, and also 22 kilowatt PV put in. So they certificate really zero energy building. So it already exists. This is coming to something like a big boom in Japan for zero energy family in a building. And also housing. We have so much small detached house in Japan. So, you know, the countryside and even in the city, we have a wooden house, very typically 2 or 3 stories. And we defined first a minimum U value and at least 20%. It's not so severe for 50% with PV or renewable energy and on-site energy only. And this is a zero energy house, not a zero energy hotel. So we call ZECHI in Japanese, the 100%. And we provide a subsidy for the customers. 2012 is only 443 houses get the subsidized. But from, we defined the definition, 2015, it's a big boom is coming. Over 6,000 detached house the new house get the subsidy. And the last fiscal year, over 12,000 house have a subsidy. It means already built. So we predict maybe until 2020, 200,000 new house, detached house, maybe for the zero energy house, but it's not include appliances. And then it's the first 1,000 houses, we already have a data for 3 years measurement data. What we found is this is the energy consumption in a house, and this is renewable energy. Over this line is zero. Without plugging in, 64% houses for 980 is zero. But even with the appliances, 31% of the houses is zero energy. So now, not just called the energy conservation house, but the zero energy house, high quality, and also for less energy. So, and we put the mark also, labeling scheme. We ask the government that you can put the zero energy house in your labeling scheme. So 50% off for the standard value, then you put in the PV on the roof. And of course, it's research is not only on the real market. We built like a solar decathlon in Japan. This is our first zero energy solar decathlon house in Japan, 2014. Unfortunately, University of Tokyo won that time. And 2015, so we built again. So we won. So it's our live house. And also this year, we have another contest in Osaka. So now the students work very, very hard for that. And of course, it's not just for energy conservation, but also, for example, when we start to use the PV, so it means you have to stretch sometime in the daytime. Of course, the battery is very expensive, but hybrid car in the EV is getting cheaper and cheaper. And also, we have a CO2 heat pump tank. Now it's a daytime, so we may try to heat pump its move for the hot water, domestic hot water, it's stretched in the daytime. And also for the weather forecast is one of the very big issue for research. For next day weather forecast, sunshine, solar radiation, and raining. And also for the grid technology. So we have collaboration with 5 university professors for different fields, and mechanical, electricity, and building, and economist. And this is one very simple one. It used to be eco building is less electricity from the grid and less from the gas pipeline. But now it's very smart. So sometimes electricity going to the grid, and also for some, we have fuel cell, so hot water going to the gas company. And now we also control the information technology as everybody combined to the smart one. Very rapidly. This is our research facilities. We have combined open ADR system for the grid simulator, and also fuel cell, the heat pump, and EV and battery as control panel, PV controllers, and smart meter. Actually, for our electrical department professors heading this, and we're 5 university professors working at Waseda with this kind of things. Of course, it's please consider the comfort. This is also very important things. And also, almost last slide, Asian country. So here is primary energy demand. So how much energy they expect to use. Japan is not more change, big change, maybe keep stable. But China, so it's 9 times more energy, primary energy, they use for next 20 years. And then also India and South Asia and the Middle East. This is the key. And also this is the share of the global growth. So 65% of economics income coming from non-OECD Asia. So that's why people going to the Asia for this region. And one of the topics, this region is hot and humid summer. So that's why we need a UBGI, and also for the dashcam system, and how much not overcooled. In Singapore, they overcool 21, 22 degrees. This is stupid. So we need the comfort study, indoor environment, and of course, the same time for the energy. This is my conclusion. So DTU is the center of indoor environment and energy research, of course. Since 1984, it's already a center. And also ESG investment is very important. And build green and live healthy and smart is also important too. Zero energy building is the final ultimate goal. Its energy management system, EMS, is key for the future. And non-OECD Asian countries have more impact on economy and energy. Thank you very much. That's it.